Boom. What is up, everybody, and welcome back to another Flow video. This is Jacob Tucker, and I'm going to be showing you how to create your first ever dApp on the Flow blockchain using the local Flow emulator. So we're going to go over a lot of beginner concepts today, including the FCL dev wallet, what even the blockchain is, what does emulator mean. So let's dive right into it and skip the boring introductions. So in order to actually get a Flow dApp up and running, you're going to need to install the Flow CLI. So this is at docs.onflow.org /flow CLI/install. I'll put the link in the description. And you're gonna have to scroll through here and basically find your operating system. So Mac OS, I would just copy this line into a terminal. Linux, I would just copy this line into a terminal. And Windows, you copy this line into a terminal. I've already done that. And when you do that, you should be able to type flow version, and it will give you back a version, and that's how you know that you are successful. So what I'm going to be doing in this video is working in this repo called Flow Local YouTube. I couldn't come up with a better name. And so it's basically a base Next.js project. So if you're using React or anything else, it should be the exact same. But I'm using Next.js because I figured that'd be helpful for most people. So what I have right now is a base Next.js project. I haven't really done anything. The only thing that I've done that you're going to have to do is install @onflow/fcl and @onflow/types. So if we actually go to our terminal together, if you do npm install @onflow/fcl and @onflow/types, you should be good to go. So those are the only two things you're gonna need to install, and I've already done those, so I'm not gonna do that now. But while you have that installing, let me actually explain what the local emulator is and why we're going to be building on something called an emulator in today's dApp to help you get started on the Flow blockchain. So on the blockchain, there are three things. There's three different types of development. There's the local emulator, which is where you always start. This is all fake. It's all on your own computer, so no one can interact with your local blockchain except for you. It's perfect for developing and unit testing. And the reason for this is because, one, you can reset anything whenever you want. So if you have a contract and you're testing it and you realize there's a mistake, you can remove the contract and redeploy it almost instantly. So it's super easy for developing. For unit testing, it's perfect because you can spin up a new emulator and just test all your code immediately. So it's really great for developing. Now, testnet is where you go to on the next layer. Now, I'm not going to talk about these too much because we're going to be talking about the emulator today. But in case you're curious, the testnet is, the next layer up. It's still fake, so there's no actual real things going on testnet, but it is on an actual chain, so everyone can interact with it, right? Everyone can interact with testnet. So if you deploy a contract, everyone can look at it too. It's perfect for testing your code in a real environment, even though it's technically fake data and everything, before you go to mainnet, which is real. The transaction times are what they would be on mainnet. So again, it's great for testing a real environment, and it uses real wallets like Blockdo, but again, it's still sort of fake. And it's not great for developing because redeploying your contracts and testing takes a long time on testnet, where it doesn't on emulator. And then mainnet is real. That's where all the real applications are. So it costs real money. It's scary if you mess up. Everyone can interact with it. It's what you use to interact with actual applications. So mainnet is the real deal. So today we're going to be going over the local emulator because that is where you want to start your Flow journey. Now, I've done a video already on developing on testnet, so I'll link that in the description if you want to view that as well. All right. So you should have @onflow/fcl and @onflow/types installed. So let's go ahead. And this is a base Next.js project. I haven't done anything. Oh, I've also included some styling, but that's not really the point of this video. And all this source code is going to be on GitHub in the description. If you want to look at the source code, you can totally go ahead and do that. Also, yes, my hair is wet because I just got out of the shower, so don't flame me. Okay, so what we're going to do first is inside of our index.js, we're going to import all as FCL from @onflow/fcl, and then we're going to import all as T from @onflow/types. So boom, we have imported our two libraries. Now, what FCL is going to allow us to do is that's going to allow us to actually interact with our local blockchain. So this allows us to send transactions and scripts, and I'll explain what those are in a bit, and actually deploy contracts and stuff. And the types is what we're going to use to actually supply arguments to those calls. And again, I'm going to go over all this in a bit when it makes more sense. All right. So what I'm going to do here is I'm just going to put hello idiots inside this div, so that what we can do is we can npm run dev our project, and we can load it up and start looking at our application here. So hopefully it should load up soon. Boom, we see hello idiots, perfect right there. So we know that it's working, and we can start, adding some logging in and logging out. Why don't we do that first? So before we do that, what we're going to have to do is actually configure our FCL to point to the local emulator. So in order to do that, we're going to say fcl.config, and we're going to open up this little object here. And the first thing we're going to do is say access node.api, and we're going to point this to, let me look at my notes here. We're going to point this to localhost. So localhost, HTTP localhost 8080, just like that. Now, the next thing that we're going to do is we're going to point something called discovery.wall, and I'll explain all this in a bit. And we're going to point this to this link right here. So I'm going to copy and paste this in, but I'm going to give you some time to actually copy this down. So you point the discovery wallet to http localhost 8701/fcl/authn. Now, you may be wondering what both of these do, and I sure as heck was when I started. So access node.api, what this is doing is this is telling our application to look at the emulator. So if we were looking at testnet, we would put something else here. If we were looking at mainnet, we would put something else here. But emulator is always going to be 8080. Now, discovery.wallet is telling us what wallet we're going to be using to actually interact with our local emulator. So this is going to allow us to use the dev wallet. Now, the dev wallet is a pretty cool feature that I'm going to be showing you how to use in a bit, and that's what we're going to be using to log out, log in, create new accounts, have accounts to interact with our local emulator. Okay, sweet. So now that we've configured our FCL, we can actually go ahead and implement a login and logout mechanism to help us get started. So let's actually return a. We're going to return a a bunch of stuff here. So we're going to return a div, and inside this div, we're just going to have a button. So let's just have a button here, and this is we're going to say login, and then we're going to have another button that is log out. So let's have log out right here. Now, inside of these buttons, we're going to add an on-click handler. This is going to happen when you actually click the button, and we're going to open, and we're going to just call a function called like login or something. And for this one, we're going to call a function, and we obviously haven't made these functions yet, called login and logout. So first of all, let's go ahead and add a new function called login. Now, login is going to be a function like this. Function like this, and inside the login, we're going to say fcl.authenticate. Now, what this is going to do, fcl.authenticate, this is going to bring up a prompt for us to actually log in. And similarly, let's actually copy and paste this function and make a function called log out. And it's going to be fcl.unauthenticate. And this is going to allow us to log out. Sweet. Now, what we can do is we also want to store information about the user that's logging in. And so this is why the next part is also pretty important. So what we can do is we can use something called useEffect. So this is actually comes from the React library. I don't know why it always auto imports it from some weird location, but you're going to import useEffect from React. Now, what this is going to do is allow us to run something every time the page refreshes, also known as, or AKA, every time the user logs in and logs out, so we can update information about our user that is logged in. So inside our useEffect, we can say fcl.currentUser, like this, .subscribe, and then inside .subscribe, we're going to pass in something called setUser. Now, we have to define what setUser is to actually set some data about what the user is that's logged in. So, and this will all make sense, by the way, once we've finished this part, but just sort of stick with me here while we're getting this base information out. So we're going to use something called useState. So let's say const user, comma, set user. This is just the syntax you use for useState. And then say equals useState. And then we're going to pass in an empty object here. And we're going to set ADDR to an empty string. Now, I'll explain why we're doing that in a second. I know I keep saying I'm going to explain this in a second. And I promise you I will in a second. So we've defined set user, and set user gets passed into the subscribe method right here. Now, what this is going to do is every time the user either logs in or logs out, it's going to update the user object by passing in set user to the subscribe function, and that's going to store our user's information inside this user variable. All right, so what we can do down here now is inside of our div, we can say, you know what? If user.addr, so it's the same thing as saying like if user.addr, but this is in JSX syntax. So if user.addr, then let's display user.addr. Otherwise, we're going to display an empty string. Now, the reason that I still told you I would explain this, the reason that I put in ADDR as an empty string here is because if the user is null, then at the very least, ADDR will be defined to something, so this won't throw an error here. Because if we didn't initialize this, it would say, wait a minute, user's null and you're trying to access ADDR on it. That's not going to work. So that's why I initialized ADDR here. Okay, now, one other thing I want to mention, so in order for us to log in and log out, we actually need to run the local emulator on our computer. The reason for that is because if we run testnet or mainnet, all of the blockchain is hosted somewhere else. It's hosted by a bunch of nodes on the blockchain. But this is local emulator. It's all on our computer. So we can't actually log onto an account using a wallet that doesn't exist if it's not running. So let's actually go to our terminal here. And let me just CD a bunch of times because I'm an idiot and structure my computer like an absolute degenerate. But let me do /YouTube/ I think, what did I even call it? Oh no. Flow local YouTube. So let's do that. And then once you go to your your directory here, what you're going to do is you're going to type flow init, right? Just like that, flow init. Now, what this is going to do is it's going to create a flow.json at the project root. Now, flow.json is what's necessary to define some parameters about your blockchain and where your contracts are living and all that kind of fun jazz. So we need a flow.json in our project root. Now, the next thing we can do once we do that is a flow emulator start, and then let's just do flow emulator start. So boom. And what that's going to do is that's going to start up our local emulator here, you know, and it looks pretty cool, right? So we have a local emulator actually running on our system. So this is sort of like a blockchain, right? We just started our own little blockchain on our computer, which is pretty cool. So let's go ahead to our website now and refresh our page here and click log in. Now, if we've done everything right, and it doesn't look like we have because it's not working, so that's absolutely fantastic. But if we let's actually so maybe what we can do is let's restart our application here, and maybe that will work. So we've restarted our application, we click login, and it's still not working. Perfect. Okay, so I've done something wrong. So let's see what I've done wrong. Oh, I know what I did wrong. So I forgot to start the dev wallet. So okay, I'm actually glad I made this mistake and showed all of you. So the Flow emulator, what this is going to do is start up our own blockchain on our computer. Now, what I forgot to do is also start up the wallet, because just because the blockchain's running doesn't mean that we have a wallet to create accounts and actually log in. So when we do Flow emulator start, we have to do --dev-wallet. Just like that. And if we click enter here, now it's going to start the emulator, and it's going to also start our local, our dev wallet. So if we refresh this page and click on login, now it comes up with our wallet here. So you'll see there's some missing icons and it says untitled DApp. We can fix all of that in a second here. But what's cool is that it actually gives us some options to log into some accounts. So the service account, you can think of that as like an admin account. It's pretty much just an admin. You can see that when the emulator gets started, that's actually the base account that's created. So F8D, right? F8D. And then it just also creates a user account called account A for us. So let's just log into account A. Now, what's really cool is that we've logged in, and now look, it prints our address to this screen here. And if we click log out, it gets rid of it. And if we click and log in again, and we click on, let's say, the service account, boom, there, it's rendering our address there, which is super awesome, right? So yay, it's doing that. Now, the next step here is going to be actually, you know, maybe making this wallet look a little bit nicer. So I'm not going to take too much time on this because I want to get to the, you know, more important parts of the video. But if you want to configure some cool things like the title and stuff, I'm gonna paste in this code because, again, I don't want to waste too much time on this. But let me paste in some code here. So you can do app.detail.title, and you can put a string here. So Jacob is a legend. I mean, that's a given, right? And you can also do app.detail.icon. Now, what I've done ahead of time, of course, because it's me, is I have basically configured my own little picture here, so that if I go back into here and replace this this Imgur image, now every single time that we go through an example, you're going to have to look at my face in sunglasses. So I did this because I have the power to do so, and I think it's amazing. So now we have Jacob is a legend and a picture of me in sunglasses, and the best part is this is what's going to be uploaded to GitHub. So when all of you go and use the source code, you're going to have to look at me in a pair of sunglasses. Amazing. So that's just some fun stuff you can add to your dev wallet. Now, what we're going to do in the next part of the video is go over how to actually deploy a contract to our local emulator and run some transactions and scripts, that have to do with that contract so that we can start actually using our dev wallet. So let's go ahead and let's make a new folder called Cadence. Now, inside of this folder, what we're going to do is make a new file called stuff.cdc, and this is going to be a contract. So for the record, you're going to notice that actually I have like syntax highlighting here. So in order to do that, what you're going to need to do is install this Cadence extension. I think you can actually do that on the Flow website. So let me actually go to the Flow website to help you all out. You can go to docs.onflow.org and click on Flow VS Code extension, and you should be able to, if we scroll down here, there's a lot of BS here, but if you just do this in your terminal, Flow Cadence install VS Code extension after you've installed the Flow CLI and done Flow version, like I showed you at the beginning part of the video, if you run this piece of code, it should automatically put the Cadence extension in your VS Code. God, I don't know why I couldn't think of that. And now you have syntax highlighting. So what we can do now is I'm going to keep this contract very simple because, again, this is sort of like an intro to Flow, an intro to DApp development. But I have a whole series, and I literally mean an entire series on Cadence development from zero to hero, I always say. And it covers some pretty, complex topics. So if you want to learn Cadence, I really recommend checking out that tutorial series. It's, I think, probably the only series out there that actually teaches Cadence. So, yeah, so I'm going to keep this contract very simple. Just stick with me for now. And if you don't understand Cadence and you're curious about it, definitely check out that video. So in here, I'm going to say public var name. So this is just a piece of state. So we're storing a public variable named name, and it's a string. And then we're going to have a function here called change name that takes in a new name that is a string type. And all it does is say self.name equals the new name. So it changes self.name, which is this, to the new name right here. And we're going to go ahead and initialize this and say self.name equals Jacob Tucker. Okay, so the reason I'm doing it this way and making a very simple contract is because when we deploy this contract, we're going to run a script that gets the name, and then we're going to run a transaction that modifies the name. So at the beginning of this video, I said I would talk about what transactions and scripts are. Scripts are things that read from the blockchain, so they never modify the state, right? They would never change anything like the name here. And transactions are what cost actual like gas or money. And that transactions actually modify the blockchain. So in order to change the name, we would have to run a transaction that modifies it. And to read the name, we would run a script that reads it, right? So that's just some helpful terminology. And then in this init function, this is what gets run when the contract's actually deployed and sets the name to Jacob Tucker. And then, of course, we can run any transaction we want to change it or any script we want to read it. Okay? And again, if you're curious about Cadence, check out these series. Wow, this is shameless self-promoting. Okay, so let's go back to our application and let's figure out how to actually deploy this to the blockchain. So to do that, we need to configure our flow.json. This is why we actually made the flow.json in the first place. And for the Flow emulator, of course. So inside this contracts object, what you're going to do is open up a string here and put the name of your contract. So in my case, the name of my contract is stuff. And what you're going to do is in this next string, you're going to point to that actual file. So I'm doing dot, it's always from the root. So /cadence, so cadence and then /stuff.cdc, boom, just like that. Now, inside of deployments, we're going to do, so open up this object and type in emulator. Then open up another object and type in emulator account, and I'll explain this in a second. And then open up an array and type in stuff. So what this does is under the deployments object, you specify the chain, so emulator, and then you open up an object, then the account, which is already defined here for us, emulator account. You type in the account name. Then you open up an array and you put all the contracts you want to deploy. Now, if we wanted to do this on testnet, we would do like testnet, right? And then you'd have like a testnet account, but we're not going over testnet in this video. All of that's covered in the video that I mentioned earlier that I'll link in the description. Wow, I am on a self-promoting craze right now. Okay, so now when we go to, let's open up yet another terminal. This is exciting. And go to YouTube and then go to Flow. What the heck did I call it? YouTube? Wow, okay. So let's go ahead and type in flow project deploy -- network equals emulator. And when we run this, it's going to hopefully, wow, I am a legend. it's going to take our stuff contract and deploy it to the service account, or basically to the account that we specified right here, which is emulator account. And you can see the emulator account is F8D6E, all that stuff. And look, that's exactly the one that we see right here. So now stuff is actually deployed to our local blockchain, so we can run some scripts to read from it. So heck yeah. And one thing I want to point out is that because we just deployed that, we actually see that there's some logs inside our emulator here, right? It's telling us, hey, a transaction was executed, and that's because when you deploy a contract, it's really a transaction. So that's why it's giving us a transaction here. All right, so let's go back to our application here. And yeah, so now we're inside our app. Okay, cool. So first of all, before we continue, I just want to add some fun little styling to our project. So right now, what we're doing is if the user.address is not is a thing, we render the address. Otherwise, we render nothing. But we want to make our application look a little nicer. So we want to say, hey, if the user's logged in, we only want to render the log out button. And if the user's not logged in, we only want to render the login button. So what we can do is we can actually say up here, if user.addr, like that, we can return this big thing, and otherwise, so else, we return something else. So inside the else, this is what is happening if the user is currently logged out. So we can render, let me just do this. So div class name equals center. So I told you I already have some pre-made styling, so it's kind of like, just follow me along here. Class equals button -1. And then in here, we put the fcl.authenticate button. So that is the login button. So let's go ahead and put our login button right here. So let me just make sure this is all right. So fcl.login. Oh, and this needs to be like a little span. And you'll see why. It actually looks pretty cool. I'm not going to lie. So we'll put login inside of here. Okay, cool. And then if the user is logged in, then we want to put like the log out button, obviously, right? So if the user is logged in, we're going to do the same thing. We're going to render a div with the class name equals center. All right, and then inside of here, we're going to make another div. Wow, my front end is really disgusting. And we're going to put the user.address right here, and then a button that says log out. So let's go ahead and take this button, put it under here. We can delete this now. And this button is going to also have all that like fun stuff. So we need to add the span here. /span. All right, take our log out, put it inside the span. Awesome. And then we should be good to go. Oh, I also forgot, because my front-end styling is fantastic, that this actually has a class of button2. Awesome. And then we're going to put our button inside of there. So again, this is all just like front-end styling stuff. You can totally ignore this if you want. But now, hopefully, I think our application should look pretty cool. So if we X this out and refresh the page, look at that. So it's a little login button that has a cool animation, right? I know, I'm pretty much a legend. Also, just for the record, these should be class name because it's React, right? So it's giving me problems about that. So now it should be fine. Okay, cool. So now we have a login button. If we log in, it gives us, wow, there's me. God, I'm so hot. And we can click on account A, and now it renders our address here and then a log out button, right? So cool stuff. So let us now add some scripts and transactions to actually interact with the blockchain. So what I'm going to do now is, if the user's logged in, obviously, we're going to be working in here from now on because the user's logged in, obviously. So we're going to add a new div here. So let's add a new div. And inside of this div, we're going to add another div with a class equal to, or class name equal to button1. Okay. And inside of button1, we're going to add a new button that has an on click equals get name. So this is going to be used to get the script. Then we're going to open up a span and say get name. Okay. So inside of here, what we're going to do is we're going to have a new function called const get name. Const get name equals a new function. All right. And inside of here is where we're actually going to run a script to get our name. So let us say const response equals await fcl.send, and I'll explain all this in a second. fcl.script. Okay. And just like that. So what this is doing is and this needs to be an async function. So response is going to be the result of our name here. So we're trying to get this name right now, right? So name is going to be, we're going to say fcl.send. So you always say that to like do something on the blockchain. We open up an array here. And that's where we pass in some arguments. So the first argument is the actual script code. Like what's the cadence code to get the name? Well, you can do fcl.script and you have to pass in like a little string here. So we can say import stuff, and again, this is all cadence, so I'm not going to go too in depth on it, from ox stuff, and I'll explain that in a bit. Public function main. It's going to return a string because we are returning a string right now. back to the client, and all we're going to do is return stuff.name. So again, stuff.name will be this variable right here. Now, what does this mean, OX stuff? Well, what we can actually do is instead of putting like OX, like F8D, DD, all that stuff, which is kind of ugly, what we can do is configure this inside of our, we can actually configure this inside of our config itself. So inside of here, we can say, okay, OX stuff actually points to an address. Now, if we go to our, our flow.json, when we deployed this contract, we deployed it to this account, right? Emulator account. So let's take this address, add a OX in front of it, and boom, now OX stuff will actually point to that address, but it looks much nicer in the code here. And now we can reuse OX stuff without having to copy and paste this address over and over and over again, right? So here's our script code. Then we're going to say .then fcl.decode. So we're going to decode whatever it comes through the response. And then we're going to say set the name to, set name to response. Now, we haven't actually defined what set name is yet. So let's go back up here and have a new state called const name and set name. All right. And this is going to be equal to useState, just like that. Now, we have this name variable, which is where we're going to store the result of our call, and set name, which is how we set this name. So down here, we set the name to be the response, which is like the result. And then inside of here, we can actually render, let me go back to my notes here, xd. So we can actually render a h3 here that is the name, okay? So let's see if this actually works. So if we go back to our application, so here, we're logged in, it's going to say get the name. If we click get name, look what actually happens. It returns Jacob Tucker. Now, that's because inside of our contract, we initialized the name to Jacob Tucker, right? So this is working perfectly fine. All right, so that's an example of a script. Just to go over that again, what we did is we awaited a call to the blockchain. We said fcl.send. We passed in our script code here to actually get it. This is Cadence code, but it's pretty self-explanatory, right? You import the contract. You say this is our main function, and inside of our main function, all we do is return stuff.name, which is this variable. Awesome. So for the next part of the video, we're going to go over how to run a transaction. So a transaction is something that modifies the blockchain, right? So we're going to be calling a change name to actually change the name. So let's go back down here. Let's add a new div, and we're going to add some cool stuff in here to change the name. So let's, once again, I'm just going to copy and paste this div up here, just so it saves some time. In the onClick, we're going to say change name. So it's going to be a new function, and we're going to call this change name. And now we're going to also add an input. So we're going to add right here, we're going to add an input element so we can actually input some text into the website to put in our new name. So the type is going to be text, because we're going to be putting in some text. And when we input something into this, when we type something into the input, we're going to do something with what we're typing in. So we're going to say set new name to be e.target.value. Now, what this is going to do is, I'll explain this as well. We haven't defined set name yet, so it's going to take whatever we're typing into the input, set the new name, we haven't defined this yet, to be e.target.value, which is just the text that we're typing in. So up top, we can say const new name, and then set new name equals use state. So this is just another piece of state. I almost misspelled that. Wow, that would have been a pain to debug. So now when we actually go to run a transaction, it will give us the, it will give us whatever we had typed in here. So just to, it's giving us an error because we haven't actually, defined change name yet. So if we go to our application here, we can say const change name is going to be a new function. And it's sort of a similar process. So const transaction ID. So a script returns some data. A transaction returns a transaction ID. So equals await fcl.send, just like a script. The only difference now is we have to say fcl.transaction instead of fcl.script. We can pass in our transaction code here. So it's actually going to be pretty simple. We're going to import stuff from OX stuff. We're going to say transaction. We're going to take in an argument, which is going to be the new name, which is a string. And this is all Cadence code again. And inside of here, remember, two things happen if you know Cadence. There's a prepare phase, which has a signer. So this is the person that's actually submitting the transaction. And then there's an execute phase, which actually does some stuff. So inside the execute phase, we can call stuff.change name with the new name. So let's go ahead and say stuff.change name. and we're gonna say the new name is new name that we're passing in right here. So this new name, this is the argument label. This is what's right here, and then this new name is what we're passing in as the argument to update the value. All right, so this should be a fine transaction, and after we do that, we have to actually pass in the argument for the new name, right? So what actually is the new name? Well, you can say fcl.args and then open up an array, and then here you say fcl.arg, and the arg is going to be the new name, and this new name is coming from up here, right? So there's a lot of new names going on, but you can sort of get the idea. Now we have to specify the type of new name, which is t.string. Okay, so I told you at the beginning of the video, I would explain what t is being used for. Remember, t is being used to actually specify the type of our arguments. So down here, we say new name is a t.string, okay? Then, because it's a transaction, we have to specify some other things about our transaction. One of them is the proposer. So on Flow, there's 3 roles when you send a transaction. There's the proposer, there's the payer, and then there is the authorizers. So let me explain these once I write these out. So authorizations is an array of scl.auths. Okay, so just to point this out, so on Flow, when you send a transaction, there's 3 roles. There's the proposer, which is the person that's actually like initiating the transaction. There's the payer, which is the person paying for it. Now on the local emulator, it's all free because it's all on your own computer. And then fcl.authorizations is an array of people that are authorizing it. So everyone that authorizes it is going to be put in here as the signer. So if we had put multiple people in this array, there would be signer 1, there would be signer 2, that's also an auth account. You get the idea. And the auth account is what allows us to access the account's data. So that's all more complicated cadence stuff, and definitely check out the series. There's another self-promotion for you. So what we do is we say fcl.proposer, fcl.payer, fcl.authorizations, and what we pass in is fcl.authz. Now, fcl.authz is the current user that's logged in through the dev wallet, okay? So that's that's basically you, whoever you're logged in as. So we're going to be proposing it, paying it, and authorizing it. And then one other thing you can add here is fcl.limit. Now, this is just a gas limit, so I always set it to 99999, so I never get any problems. And then we're going to say .then, fcl.decode. And what we can do is we can console.log the transaction ID. Now, the transaction ID is what gets returned from the transaction, so we just know what happened, right? So cool. When we click on change name, it'll call change name, and it'll pass in as an argument the new name that we typed in this input. Now, if we go back here, oh, now it's giving us a problem. The problem is that we said await, but we didn't make this function asynchronous, so we have to make it async. So if we go back to our application here, we can type in like Bob Vance. I don't know if any of you have ever watched The Office. And if we click on change name here, it's going to come up with the FCL dev wallet. Now look at all this, right? So it says account A. This is just the name of our application. And look at the 3 roles here. So the proposer is who we are logged in as. The payer is me as well. The authorizers is also me, right? It even gives us the name of the account. Now all this is fancy flow stuff. The proposal key is just the key ID that we're using to sign the transaction. It's complicated, so don't worry about it for now. This is a little complicated. The gas limit, remember we specified that. This is all complicated stuff. Don't worry about it. And then here, you can actually view the arguments. So the first argument is an object, the type is a string, and the value is Bob Vance. That's what we typed in. And this is the transaction code that we're running. So this should look very familiar to you. Now notice that, look, even the import got changed here. So remember I told you that when you put OX stuff, it actually changes it to the address that we specify in the config up here. So when we go back to our thing here, this is the transaction code. And when we click approve, you'll notice that it logs the transaction ID here. And then if we click get name again, now it is Bob Vance. So that is really cool stuff. Now you can even see that on our emulator, a lot of this is getting printed to the console, right? Script executed, transaction executed, script executed, right? Let's click it again. Let's click get name. We clicked it again. Boom, it logs script executed. Now, one other thing that's really, 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 really cool about the local emulator is that it allows us to log stuff inside of our cadence code. So you can't do this on testnet and you can't do this on mainnet. But what you can do is inside of our transaction, for example, let's say we want to log to the emulator the address of the person who's sending the transaction or authorizing it, right? So we can put a log here called sign, and we put signer.address, and let's see what happens now. So if we save this file, we have to do some annoying stuff. So let's cancel this out. Let's restart the emulator, but this time we put a -v flag. Now this basically means that the emulator will be verbose now, so it'll actually print logs to the console. So if we run this emulator now, we of course have to redeploy our contract, right? Because we restarted the emulator. So we have to now redeploy the contract to the emulator, okay? So when we go back, if we sort of like refresh this page here, and we click on get name, it'll log Jacob Tucker, right? So you can even see that in our emulator, it's logging some more like verbose stuff now. But let's go ahead and see something. So if we change the name to Bob Vance, let's change the name. Now it was giving us a problem. So cannot. Oh, it's because we have to log back out and log back in. So let me just refresh the page. So when you restart the emulator, I would recommend logging out, logging back in. So let's do Bob Vance here. Change the name. Click approve. And now inside of our emulator, you can actually see, here's a log, and it logs the address of the person that sent it. And you can even do this for scripts or transactions, right? So inside of my script, if I want to log like, I love chocolate chip pancakes, woo, there's a typo in there, but I don't care, right? If we log that, then let's see what happens. So if I run the name again, boom, oh, there should be a log. I love chocolate chip pancakes. So this is a super cool thing about the emulator is you can add the -v flag and you can put any logs that you want. And, of course, I just put this stupid stuff here, but this is really, really, really helpful when you are, debugging your code. Because, when your contract gets super long, you can even put logs in here. Here, I'll show you this one too. So let's go ahead and log the new name, right? So it really helps you debug your code. So let's go ahead and log the new name, right? So if we cancel this out, let's do the emulator. Let's redeploy our contract, right? Did I just do it? Okay, so it redeployed. It's only giving me the error because I ran it twice, but we redeployed the contract. We go back to our code here. Let's log out. Let's log back in. Let's do account A. Let's change the name to poop. Let's change the name, approve. And if we go to our log here in the emulator, you'll see, oh, look, it logs the name here. So poop, right? That's coming from our contract right here. So it's really helpful to log stuff. Now, one more thing I want to show you, this is the last thing I promise. I know this video has been pretty long, although I've tried to keep it short, is that you'll notice that every time that I stop the emulator, right? So I stop the emulator, I have to restart it, right? Then I have to redeploy the contract. And then if I had state that was in my application, right? So for example, right now when I click get name, it resets it back to Jacob Tucker because we redeployed the contract. If you want to, in between each emulator restart, you can actually persist or save the data that you had beforehand. So let me show you an example of that. So if you cancel out the emulator here and you do the same command, but you also add a -- persist flag here, okay, you run that. Now, if we deploy the contract, okay, let's log out, let's log back in, let's do account A, and let's change the name to Bob Vance. Now, if we change the name, click approve, now get the name, it's Bob Vance. Now, what happens if we cancel the emulator and restart it? Let's go back to our application. Let's refresh the page. And if we click on get name, look, it's still Bob Vance. It didn't reset back to Jacob Tucker. And this also means that our contract is still deployed now. So if we add the persist flag, it keeps all of the data that we had in between emulator restarts. So that's all I had to show you for this video. I hope that was really helpful. And again, this is all emulator stuff. If you want to check out how to go to the next step on testnet, that includes a whole new variety of things because you have to actually deal with a real chain. You have to deal with like real wallets like Blockdo. It gets pretty complicated quickly. You have to deploy to testnet, which is a little more complicated. So definitely watch that video and check that out. But I think this was actually a pretty good video on the local emulator. So if you enjoyed the video, smash that like button and definitely smash the subscriber badge. And I'll see you in the next one. Peace out.